Hello and welcome to the module 4. In this module, we are going to talk about, I think, the most important component of the semantic web, which is basically creating the foundational layer of the semantic web, and that is resource description framework. So this particular framework has got different other subcomponents. So the first thing that we will discuss is what is basically the resource description framework or RDF is. So what kind of protocols or standards that are useful while we represent something in resource description framework. The second thing is what kind of language or protocols that we can use to assign sense or describe the semantics of a data which has been published in RDF form. And the third thing that we will consider is how we can query our database or the web of data using something like SparkQL, the query language for the semantic web. So these are the three distinct parts which will be relevant in this module, right? So in part 1, we will be focusing on primarily on the resource description framework, that is RDF, and RDFS, which is RDF schema, right? So let us get started with RDF. So in this part, we will be focusing, or in this module, we will be focusing on RDF, RDFS, and SparkQL, right? So to introduce RDF, we are describing the resources that are there on the semantic web. So they are the core elements in the semantic web, and you can think of anything like web page, image, video, etc. to be one resource. And one thing that we need to remember, that every resource should be identifiable by one URI. So this is one thing that is you have to kind of abide by if you want to publish something on the semantic web. The second thing is that we are describing the resources with a set of attributes or the relations, and these set of relations or the set of attributes along with their values for a particular entity is called the metadata of that particular resource, right? So we describe the resource with the help of a set of relations, and that description is called the metadata of the document, right? And of course, you know that this is pretty much required in order to understand or reason about the resources. And we need to talk about different models, languages, or syntax. Whenever you have language, you have got the syntax and the semantics to represent this description in the first place. In the second place, to publish these descriptions on the semantic web, right? So that's why we call it as resource description framework. Now RDF, as we know, it's a graph-based data model, right? We have seen earlier. So to give an example, we are describing Lionel Messi, and Lionel Messi is the current member of FC Barcelona, and Lionel Messi plays in the forward position, and he is of type soccer player, right? So this is something that we have extracted from DBpedia, and you can see that these relations along with the values for an entity, they form a graph, right? Now one question may arise, let's say you know that HTML and XML, those have been used to describe documents on the web in general. So they are tree based models, right? So why we are going for a graph based model, right? Let us see what are the kind of logic that is there to support this graph based model. So here what we do, we are basically describing relation, right? It's not like you have a clear structure of the document. We are just describing the entities, and these entities, they are connected to the other entities with the relations, and the relations, they can be thought of as edges or the links between a pair of nodes. So these descriptions, if you draw, they form a graph. So this is kind of intuitively the graph is coming into picture, right? But the other thing that is pretty much syntactic in nature. Now if you see the information in the World Wide Web, so they are decentralized. What do you mean by that? So one can publish a data without looking at what others are publishing, or the person who is publishing the document or a data, he or she can link a particular part of the document with the other part of the document, other part of the web, right? Other documents in the web. So so you see, the knowledge production is decentralized, right? Now, let's say I have created a data and I want to publish that data, and someone else has created a data and they want to publish their data. Now, I know that there is a data set out there, and I have a data set, and I want to link one data item from my data set. So this is what we are going to do. So this is my data set, and this is other person's data set. So I have an data element here, and I want to align this or link this data with another data element which is residing in other database, right? Now, you see, let us take that we have a tree structured thing, right? So if you have something like this, so you may not ensure that whenever I am connecting one data with the other data, it may not end up with a tree data structure when we connect two data sets. So for example, I can have another link here and I can connect this to this. Now it is not a graph, it is not a tree data anymore, right? Tree structure anymore. So in order to support these kind of requirements, we the semantic web community, they have preferred graph over the tree data structure, right? Now we have mentioned earlier that we can describe any fact about any entity with just three things: subject, predicate and object. And these three together, they are called a triple, right? And triple is a kind of atom of knowledge in semantic web, right? So they are kind of the basic building blocks, and if you connect them one by one, they become like molecules, right? And these molecules, you can think them to be a parallel of complex information, right? So I have tried to extract the triples that we can find in the graph that we have shown earlier. So Lionel Messi is a type of soccer player, is an instance of the class soccer player. He plays in position forward, and he is a current member of FC Barcelona, right? So we have got subject, we have got predicate, and we have got object. And we can link this Lionel Messi in this triple to be the subject. We can name this current member to be the predicate, and this FC Barcelona to be an object, right? Now let us try to take one example sentence, and you can see that you have multiple facts that are embedded here. So the sentence is: Amitabh Ghosh has written a thriller book, The Calcutta Chromosome, right? So you have got at least two facts that are embedded here. So what are the kind of facts that we can talk about? The Calcutta Chromosome has author like Amitabh Ghosh, and the Calcutta Chromosome has theme like thriller, right? Now, how do we model that? So first of all, we need to think this Calcutta chromosome or Amitabh Ghosh as entities, right? And of course, this author and this theme, they are relations. So these are predicates, and these are entities. Entities can be subject or object, right? So this is your subject and this is your object, right? Now, everything apart from the values, like this thriller, it is kind of acting like a value, right? Everything else will have a URI, right? So we map them to different URIs, right? And this thriller is becoming to be a literal or value, so we also call it as a value. Now also you can model this differently. So let us see what kind of other modeling we can do. So you can treat this Amitabh Ghosh to be a value rather than an entity. So in that case, this Amitabh Ghosh will be mapped to a literal. But you see, this design is more preferred than this because this Amitabh Ghosh here is a string, but it's better that you connect this Calcutta chromosome to an entity who is an author, and then there you can say that the name of the author is Amitabh Ghosh. That will bring in more flexibility to describe many other properties about this author Amitabh Ghosh. For example, the nationality, the other books he has written, all these things we can do. So these triples, which we are calling as the atom of knowledge, they are called the axiomatic statements. So what do you mean by that? So you can think of their kind of axioms, and these axioms, they are always treated to be true. They are always mentioned to be true. So you can think them to be uh, mm, binary predicates in the first order logic that we have seen. So what is the form of the binary predicate? So if P will be coming here and S and O will be here, right? So this would be true. So if this is true, this will be there in your knowledge base, right? So whatever that is there explicitly stated, they are assumed to be true. But what about the facts that are not explicitly claimed? So there are two schools of thought. One is a closed world assumption, a closed world assumption, and an open world assumption. So these are the two schools. So this is school of thought 1 and this is school of thought 2, right? Now in closed world assumption, it is assumed that whatever is stated, so whatever is stated, they are assumed to be true, and whatever that is not stated, they are assumed to be false. But that is not true in under open world assumption. So what do we do in open world assumption? We assume whatever is stated to be true, like we did in the case of closed world assumption, but on top of that, we treat the not stated thing differently. So we assign something like unknown, with the expectation that, well, as the data is being published distributed in a distributed manner, it's not like so your database is open, right? So whatever you have not stated, that might be stated by the others. So one can say that the thing you have not stated, that is true in their interpretation, right? So whatever that is not stated till now, the truth value of that, those facts, they should be, they are treated to be unknown, not false, right? So that is the difference between the classical rule based systems in AI. In classical AI, they are modeled under this closed world assumption paradigm, but the semantic web, in the semantic web, uh, an open world assumption paradigm is followed. Now, from the very beginning, we are telling that this semantic web, they follow a graph-oriented data model, right? So it's a distributed data model in the sense that the data is getting pumped to the semantic web in a distributed manner, and it is not really very complex or tough to attach a piece of data item to the existing web of data, right? So that's how this semantic web has been modeled. Now, you can take one example of a graph-oriented data model like we did earlier, but it has got a different purpose. So, someone has written a paper like paper 1, and paper 1 cites paper 2. Paper 1 might augment the idea that is there in paper 2, or the paper 1 and paper 2, they share a co-author, right? So what is the kind of graph theoretic modeling we can talk about concerning the RDF graph data model? So the first thing that is true about the RDF graphs, that they are multi-graph. So that means if you consider two nodes, a pair of nodes, there might be multiple paths from one node to the other node. So these kind of graphs are called multi-graphs, right? It is also a directed graph because these relations, they have directionality from one node to the other node. So even if you say that if someone is a friend of someone else, like A is a friend of B, and you assume that B also will be a friend of A, then you have to explicitly say this, right? Or we can write a rule, and from that rule it will be inferred. But the underlying model follows a directed graph model, right? And it is also a labeled graph because every edge is labeled with the predicate name, right? As you can see here, right? So the in RDF the graph is a multi-graph, it is a directed graph as well as it is a labeled graph, right? So let us take another example and see how do we translate one English sentence into its corresponding graph representation. So the kind of example we have will read like this: the book Foundations on Semantic Web Technologies (FSWT) has been authored by Sebastian Rudolph, Marcus Quetz, Pascal Hitzler, and the theme is semantic web and has page 456, right? Now if you have followed the first order logic, we can represent the facts in the form of Boolean logic or the first order logic. So I'm saying that FSWT is an instance of book, so it is a unary predicate, right? The creator of FSWT is Sebastian Rudolph. The creator of FSWT is Marcus Quetz. The creator of FSWT is Pascal Hitzler, right? And the theme of FSWT is semantic web, and FSWT has 456 pages, right? Now we can easily translate these into form of triple. We know that any predicate like PSO can be straightened or translated into triple in the form SPO. So this is exactly what we are doing here. So we are saying that FSWT is of type book. FSWT has created Sebastian Rudolph and so on and so forth. And it is very easy to see that the translation from the logic predicate to the triples is really very easy, right? Now the next task is to model this is in a graph, and as we have triples, we can easily model them as a graph. So this is the kind of entity that you are going to describe, and the predicates, they are becoming the relation or the labels of the edges, and the objects, they are becoming the nodes, right? So one example is like this fswt.pdf, which is your resource which you are describing, has got type or is an instance of a concept called book. It has got a creator like Sebastian Quetz and so on and so forth. So basically we are translating or representing them in a form of a graph. So as we have considered earlier, that everything in semantic web is a resource, right? And what are the kind of and of course the relations and the types of the resources we have talked about. The book is a type in which the particular book FSWT is an instance. So these types, so these are kind of vocabulary items which are also treated as resources. So the relations and the concepts. So the examples of the relations we have seen, the like type, creator, or the concepts like book, or we have seen earlier music artist. So these are also resources, right? So like we have a specific thing like fswt.pdf to be one resource, these are also resources. Now by the protocol of semantic web, as this fswt.pdf is having a URI, this type, this creator, this book, music artist, they are all having a URI, right? So now whenever we talk about URIs, the URIs they are represented using something called namespaces, right? So namespaces, if we remember what do they mean, so you have one URI like say http :/ something and then followed by book. So this is the kind of base URI on which you are attaching this particular concept, and you describing this particular concept there in that URL. So this is called the namespace. And we know why do we use the namespaces, basically to reduce the number of characters that will be there in the serialization format, right? So in this case, we have used something called RDF, and RDF means this particular URI, right? And whenever we say RDF colon type, then we basically we can expand this to the extended or the actual URL, which will be like the base URI followed by this type, right? This will be the URI for RDF type. So if you think this particular example where this fswt.pdf has got RDF type, the book fswt.pdf has created exr Sebastian. So here also we are assigning one URI, base URI to exs, which is basically example.org/schema, right? So which will basically define all the relations and the concepts, right? And there are certain already agreed upon vocabulary maintained by, say, Dublin Core. So this is the Dublin Core metadata description language, right? So there, from there, you are borrowing, reusing creator. You are not really creating a new relation, but you are creating a new relation like exs theme. And how we'll read that? We'll read that like example.org/schema hash, then followed by the theme, right? So there, by this URL or URI, we will be identifying this relation, right? So we use namespaces to define the schema, define the vocabularies which are used to describe any document or any data on the semantic web, right? So these URIs, they are a kind of way to identify the resources, right? So this is what it's like we can identify a person, you can identify a book, you can identify a particular music album. But how do you represent the values, the values that are related to entities? For example, the age and height of the person, or number of pages of the book, right? Or the year of publication of the book. So all those sort of things, they are called the values, right? And they are also called data values in RDF, right? So let us see how do we represent this data values. They are represented with literals, and these literals they are picked up from XML specification. So XML has got a specification language for the literals, right? So these are used directly to describe the types of the data in RDF, right? So if you think of this 25, so this is a string, and 0 to 5, this is also a string. So if you say that this string is an integer, so this is how we say something to be integer in XML, say integer, then these two values will be same. But instead of designating them as integer, if I say this is a string and this is also a string, then these two values will not be the same, right? These two will designate two different things, right? So as I have mentioned earlier, RDF directly uses the data types that are already there in XML. And you can find all kinds of data types that are required to represent any kind of data. For detailed documentation for the XML data types, you can follow this particular link. So whenever we talk about the data values, there, as I have talked about earlier, they are represented as literals. Now these literals, they can be typed or they can be untyped. So let us take an example and try to see what we mean by typed and untyped literals. So if you see, we are describing this fswt.pdf, right? Now it has got a title, and the title has got the value like foundations of SWT, uh, uh, which is of type XSD in a string, right? And we are describing the sorry, it will be date. It should be date. The date of publication of fswt.pdf is something like this, which is a string, but we have mentioned explicitly that it is a date type data. Now one would have done like this, like foundations of SWT. So here I may not specify anything specific, any specific data type to it, right? Or else we can say that the number of pages to be say 456. So I may not say that explicitly that is integer. Now if you don't do that, it is at the hand of the application developer how to interpret this. But if you have something like this, like xsd int, then you understand this is an integer kind of value, right? Now in semantic web, we also require the same string or same title to be represented in multiple languages, right? So for example, if you visit the Wikidata page for Rabindranath Tagore, you can find the uh, different ways to represent Rabindranath Tagore in different languages, right? So for that, uh, RDF provides us a facility to say or annotate the language in which the string has written. So for example, here we have used something like en. So this is a language tag, or we can say like bn, which means that the string has been written in Bengali, right? So as we assume that we have multilingual data on the semantic web, we need to explicitly say that this particular string is from a language. That will help the applications to interpret the strings in the correct way. Now to connect them together, so we can have type. So this particular statement says that this is a type literal. This is where we are having the language annotation, and here we are having untyped literal. This is untyped, right? So that brings us to something else, which is whenever we are specifying a data value, we have a lexical space and the value space. Now in the lexical space, let's say we have something like this, say 0 to 5 XSD integer, right? So its lexical space will be 0 to 5. So it's basically the string that is represented here, but the value space, in the value space, it will be mapped to integer 25. So it is a string value that is connected to the lexical space, but if you typecast that into the appropriate data type, which is annotated with the particular string, that will get you the value in the value space, right? Now this RDF data model, it has got different serializations, right? So we have talked about one serialization like RDF XML. Let us talk about other serializations. The applications, they accept multiple serializations, right? So the first serialization is I am going to talk about is n triples, right? So it's basically enumerating all the subject, predicate, and objects. So it's a very simple. You are just straightening or flattening out the graph, right? So for example, FSWT has got type book, right? FSWT.pdf has got theme to be semantic web. We are just listing down the 111, 222 to triple n. Very simple to follow. There is a bit of data representation which is called turtle. So turtle is more concise than the n triples. So here we can define the namespaces, the prefixes, and we can use this prefix values to shorten out the URLs. So here we have shortened out like RDF, XSD, EXS, and DC, right? So we are describing fswt.pdf. I am saying that that is of type exs book. So here also we are listing down the triples, but in a more concise manner than we have done in n triples, right? So we have got the theme to be semantic web. It has got two creators. One is a form of Sebastian, and other is the form of poets, and finally the number of pages to be 456. Now we can do bit better. So what we are doing here, it is right that it will be all right if we don't repeat this URL, this particular subject, because we know that we are describing the same subject. So we just represent or present this subject URL once and say that this has got RDF type book, this has got the theme to be this, and this has got the creator, this has got the creator like this. So this is how we'll be progressing, right? So you have seen that we have shortened out a bit, right? Then we can also make it more concise. So RDF type, which is a very common uh, mm, a relation that we use in describing the thing. So we have shortened this using this A. So whenever you say that FSWT PDF or AXS book, that means it has got RDF type to be book, right? It has the theme part is fine, but you can see another thing, like it has got two creators, so we are repeating the relation. So we would have written like dc.creator here also, but that is not really necessary. I know that there are multiple creators, so I just mention this property once and just say that creator is Sebastian as well as Wes. Now to do that, so here you can see that we have used a comma here because it is completing triple, but here we are using a semicolon. That semicolon says that you have completed a triple. So here you have completed a triple. Actually, it would also have been a semicolon, right? Now here we have started one triple. So this is one triple. We have a triple, but we are repeating the property. So that's why we have ended this description about multiple creators here using this semicolon, right? So semicolon stands for you have finished describing the resource for a given property, right? So here we have finished describing the resource for the creator property. That's why you have written semicolon here. And finally, we are done with describing everything and put a dot here, right? We can also have RDF's XML serialization, which we have talked about earlier. So you have namespaces, and we are describing something called fswt.pdf, and whose type is book, whose theme is semantic web, and the creator is Sebastian. So it's an XML document, clean XML document. Uh, Now we can also make it more concise, right? So we are saying that this particular resource is of type book. So we can make this shorter by saying that we are describing a book, and this particular thing is of type book. So uh, uh, we are representing the two facts in a single statement, right? And also we are saying that the number of pages for this book is 456. So we are taking this to be the attribute of this XML statement. So we are treating this to be an attribute in the XML document. We are not adding a new statement here. So you see that we can also make it more concise, right? So to talk about more detailed syntax, you can visit this particular URL, which is maintained by the W3C consortium. Now, another question may arise that how do you describe anonymous resources? So why do we need anonymous resource? So for example, I want to represent something like this, like FSWT has got type book, which we have already done, has creator Sebastian. Now this is where we are deviating from the earlier description, that fswt.pdf has got created someone or something, and that something has got a name, first name to be Marcus and the last name to be Quets, right? And this particular entity is of type person. You see that we are not explicitly saying that what is the kind of resource, who is the value of the DC creator for this particular fswt.pdf, but instead we are mentioning some properties of the resource who is the creator of this FSWT document. So let us see how do we model that in a graph, right? So these are very easy to represent. Like FSWT has theme like semantic web. It has got number of pages to be 456. It is of type, etc., etc. But let us have your attention here, right? So the DC creator uh, will expect that there should be a creator like Sebastian. Now we are not explicitly mentioning who is that, but instead we are saying that this particular entity has got type to be FOA person. The first name of this particular entity is Marcus and the last name is Quets. So this particular node, as we don't assign any URI to this, it is an anonymous node, and it is represented as a blank node. We don't have anything here. So the blank nodes are represented like underscore colon then any name, right? Now we have talked about something like existential quantification in first order logic. So this relates to the existential quantifier. So why I'm saying this? So there is a creator, there exists a creator who has the attributes like first name, last name. So let us try to write an equivalent first order logic statement for this. So there exists X for which it is true that FSWT is a creator, X is a creator of FSWT, X is a person, the first name of X is Marcus and the last name of X is Quets, right? So you can see that we can model this kind of situation using this existential quantifier from the first order logic. Now you can see that we are starting to relate the logic frameworks that we have used with the kind of framework we are talking about in relation to the semantic web, right? So, and this relation is very intricate. As we go forward, we will be having more examples of this. So there are many other constructs, very interesting constructs. So I think let us stop here, and in the next lecture about resource description framework, we will be talking about containers. So the containers, they are kind of bag, they will contain something, and depending on the type of the container, we have different ways to model different information need. Thank you very much.